But let's jump into something pretty cool today.
AI.
AI.
Sounds good.
We are looking at a paper from Meta called Memory Layers at Scale.
Yeah.
It was just published last month. And it's making some waves.
Big time, yeah.
So
a big one.
For folks who maybe haven't encountered this idea before, like what's the big deal with memory layers?
Well, for the longest time, AI has been really good at crunching numbers, finding patterns, but not really good at remembering specific things and using that knowledge, right?
Yeah.
Memory layers change all that.
So it's kind of like the difference between, I don't know, like recognizing a pattern versus actually like storing a fact and being able to recall it.
Yeah. So like instead of just recognizing a cat in a picture, it can remember that your cat's name is Mittens or the capital of France is Paris.
Got it.
That kind of thing.
So like it's kind of like giving AI a brain with a really good filing system.
Yeah, that's a good way to put it.
Okay.
Think about how our brains work, right? We don't relearn everything from scratch every time. We encounter a new problem.
Yeah.
We pull up relevant knowledge from our memory.
Right.
Memory layers allow AI to do the same thing.
Okay, cool. So how does it actually work? I know the paper mentioned something about a key value system.
Yeah.
Which sounds very technical.
It is technical, but the idea is pretty simple.
Okay.
Imagine a giant dictionary, right?
Okay.
Where the keys are pieces of information and the values are the related facts or details.
Okay.
So when the AI encounters some new piece of information, it can quickly search for the matching key in its memory and retrieve the associated value.
Interesting. So instead of having to like sort through just like this massive jumble of data every time.
Exactly.
It can just like pull up exactly what it needs right away.
That sounds very
incredibly efficient.
Yeah, and that efficiency is a big part of why this research is so groundbreaking.
Okay.
It means AI can become much faster and more accurate at tasks that require specific knowledge, like answering questions or translating languages.
So it's not just about making AI smarter.
Right.
It's about making it more practical and more usable in the real world.
Absolutely.
Okay.
The Meta researchers tested these memory-augmented models on a variety of tasks, and the results are pretty impressive.
Give me an example. Like, where do these memory layers really shine?
Okay, well, let's take question answering. One of the benchmarks they used is called natural questions.
Okay.
A memory-augmented model with only 1.3 billion parameters achieved similar accuracy to a traditional model with 7 billion parameters that was trained on twice as much data.
Wow. So you're getting the same performance out of, I don't know, like a scooter.
Yeah.
As you would out of like a massive truck.
Yeah.
But using way less.
Yeah. Much more efficient.
Fuel.
Exactly.
Yeah.
And that kind of efficiency has huge implications. For imagine, if we can get the same or better performance from AI models using significantly less computing power, it would make AI more accessible, more affordable, open up all sorts of new applications.
Yeah, that makes sense. Now, they tested these at a pretty massive scale.
Yeah.
The paper mentions something like 128 billion memory parameters,
Right.
which is just kind of mind-boggling to me.
Yeah, it's mind-boggling. And it's a testament to how far this technology has come just a few years ago. This kind of scale would have been unthinkable.
So what does this mean for the future? Like, where do we go from here?
I think this really opens up a whole new frontier in AI development.
Okay.
We're only just beginning to explore the potential of memory layers, but the early results are incredibly promising.
What are some of the areas where you think this could have a major impact?
Oh, absolutely. One area that comes to mind is chatbots. Imagine chatbots that can remember everything you've ever said to them and use that information to provide more personalized and relevant responses.
Yeah. That'll be a huge leap forward from the chatbots we have now.
Yeah.
Which often feel very robotic and forgetful.
Exactly, yeah.
Okay.
It's not just chatbots, though. Think about search engines that can understand the nuances of your questions and retrieve the most relevant information instantly. Or AI tutors that can personalize your learning experience based on your strengths, weaknesses, and past performance.
Those are some really amazing possibilities, it sounds like. Memory layers could really transform the way we interact with technology.
I think so too. And it's all because we're finally starting to figure out how to give AI a long-term memory, something that has eluded researchers for decades.
Well, now that we have a better understanding
Yeah.
of what memory layers are and why they're so significant, let's dig a little deeper into how they actually work.
Okay.
The paper goes into quite a bit of technical detail about the methods they used to achieve these results.
Yeah, that's where it gets really interesting. They had to overcome some major challenges to make memory layers work at this scale.
Let's unpack that then.
One of the biggest hurdles was just figuring out how to search through these massive memory banks so quickly and efficiently. Imagine trying to find a specific book in a library with billions of volumes.
Yeah, that sounds like a nightmare. How on earth did they solve that?
Well, they developed this really clever technique called product key lookup. It's a two-step process that drastically reduces the number of comparisons needed to find a match.
Okay, so it's kind of like having a super fast index for that giant library you were talking about.
Yeah, exactly. Instead of having to check every single book, the AI can quickly narrow down the search to just a specific section or category.
Oh, okay, I see. And to make things even faster.
Yeah.
I know they also distributed the memory across multiple GPUs.
Right.
Those are those specialized processors. They're designed for handling these huge amounts of data.
Yeah, exactly. Like having a team of librarians all working together, each responsible for a different section of the library to help you find the information you need.
That's a good analogy. I like that. The paper also mentioned something about sharing memory across different layers of the AI model. Can you explain what that means and why it's so important?
Sure. Think of it like a traditional AI model is kind of like a single massive neural network.
Okay.
Information flows through this network from one layer to the next in a kind of linear fashion.
Okay.
With memory layers, you can have multiple layers all tapping into the same pool of shared memory.
So it's almost like different departments in a company all having access to the same central database.
Exactly. And this allows the AI to kind of use its knowledge much more flexibly and efficiently.
Okay.
Different layers can access and update the same memories,
Gotcha.
which leads to better learning and performance.
It's like having different teams of experts all collaborating and building on each other's knowledge rather than working in isolation.
Precisely. And the meta researchers found that this shared memory approach led to some significant performance improvements across a range of tasks.
So it's not just about the size of the memory, right? It's also about how that memory is structured and accessed within the AI model.
Exactly. It's a combination of both the size of the memory is important,
Right.
but so is the architecture and how that memory is integrated into the overall system.
Now, all this technical innovation wouldn't mean much if it didn't actually translate into real-world results.
Right.
What kind of performance gains did they actually see with these memory-augmented models?
Well, as I mentioned earlier, they tested these models on a wide range of benchmarks, including factual questions, answering coding, even general knowledge tests. And across the board, the models with memory layers consistently outperformed the traditional models.
Can you give me like some specific examples? What kind of improvements are we talking about here?
Sure. In one test, a memory-augmented model was able to answer over 90% of the factual questions correctly.
Wow.
Compared to around 70% for a traditional model with a similar amount of computational power.
That's a huge difference.
Yeah, it is.
It suggests that those memory layers are really helping the AI to understand and retain information more effectively.
Exactly. And it's not just about accuracy.
Okay.
The memory-augmented models were also much faster at learning new information. In some cases, they were able to achieve the same level of performance as traditional models with just a fraction of the training data.
That's wild.
Yeah.
That sounds like memory layers could really be a key to developing AI that can learn much more rapidly and efficiently.
I think so too, and that has huge implications for a wide range of applications, from personalized education to scientific research.
So many possibilities.
Right.
But I also wonder about the potential downsides.
Right.
Are there any risks or challenges associated with developing AI that can store and access these vast amounts of information?
That's a great question, and it's something that researchers are actively exploring right now.
What are some of the key concerns?
Well, one challenge is making sure that these AI systems don't become too reliant on their memories.
Oh, yeah.
We want them to be able to reason and adapt to new situations,
Right.
not just kind of regurgitate information they've already encountered.
So it's like making sure that a student doesn't just memorize facts for a test, but they actually understand the concepts and can apply them in different contexts.
Exactly. We want AI that can think critically and creatively, not just act as a giant database.
Makes sense. Are there any other potential pitfalls we should be aware of?
Another challenge is making sure that these memory layers are robust and reliable.
Okay.
We don't want them to be susceptible to errors or corruption, which could lead to inaccurate or misleading results.
That's a really good point, especially if these AI systems are going to be used in critical applications like healthcare or finance.
Right.
We need to be confident that they're providing accurate and trustworthy information.
Absolutely. Reliability and safety are paramount.
Yeah.
And it's not just about technical robustness, it's also about making sure that these AI systems are used ethically and responsibly.
That brings up a whole other set of challenges. How do we ensure that AI with these vast memories is used for good and not for harmful purposes?
That's a complex question.
Yeah.
And there are no easy answers, but it's a conversation we need to be having as this technology continues to advance.
Well, this has been a fascinating deep dive into the technical intricacies of memory layers.
Yeah.
We've covered a lot of ground, from how they work to their potential benefits and even some of the challenges. But I think it's important to step back for a moment and consider the bigger picture.
Okay.
What does this research tell us about the future of AI? Where we're headed with this technology?
That's a great question to ponder as we move to our final part.
You know, it's funny, this whole conversation about memory layers, it's really got me thinking.
Yeah.
We've talked about how they work.
Right.
We talked about the benefits, some of the potential challenges.
Yeah.
But like, what does it all mean?
Well,
Where does this research fit into the grand scheme of AI development?
I think this is a pivotal moment, I would say. You know, for years, AI has been stuck in this sort of intellectual infancy, brilliant at certain tasks, but lacking that fundamental ability to learn and retain knowledge like humans do.
Yeah.
Memory layers change that.
It's like we've finally given AI a long-term memory.
Exactly.
Which just opens up a whole new world of possibilities.
It does.
Okay.
Now we can start to envision AI that truly understands the world. AI that can build upon its experiences and even reason about complex concepts.
It's almost like we're witnessing
It is, in a way.
birth of a new kind of intelligence.
Yeah, and with that comes a profound responsibility to guide this development in a direction that benefits all of humanity.
So it's not just about making AI smarter and more capable.
It's not enough.
It's also about
just focus on technical advancements.
ensuring that it's used ethically and responsibly.
We need to have thoughtful discussions about the societal implications of AI, about the values we want to embed in these systems, and about the safeguards we need to put in place to prevent any unintended consequences.
It's a complex landscape to navigate.
It is.
But it's a journey I think we need to take collectively.
I completely agree. And I think this research on memory layers serves as a powerful reminder that we are on the cusp of something truly transformative.
Yeah.
AI is no longer just a tool.
Okay.
It's becoming a partner in our intellectual endeavors.
That's a really profound thought. It makes me wonder, what will the world look like in 10 or 20 years when AI systems have access to these vast knowledge bases and can learn and adapt at this just unprecedented rate?
It's hard to say for sure, but I think it's safe to say that the changes will be profound. We could see breakthroughs in fields like medicine, education, scientific research that we can only dream of today.
But it's not all sunshine and roses, right?
Of course not. Like any powerful technology.
Potential risks and challenges.
AI can be used for good or for ill. It's up to us to ensure that it's developed and deployed in a way that aligns with our values and serves the best interests of humanity.
And that's a responsibility that we all share, right?
Yes.
Researchers, policymakers, industry leaders, everyday citizens, we all have a role to play in shaping the future of AI.
Absolutely.
Well, this has been an incredible deep dive into the world of memory layers and their potential to really revolutionize AI. I know I've learned a lot, and I hope our listener has too.
It's been a pleasure discussing these fascinating advancements with you.
Before we wrap up, is there any final thought you'd like to leave our listener with?
I'd say this: stay curious, stay engaged, and stay informed. The field of AI is evolving rapidly, and it's up to all of us to ensure that it leads to a brighter future for everyone.
Well said. And on that note, I think it's time for us to surface from this deep dive. Until next time, keep exploring the ever-evolving world of knowledge and technology.